We are surprised to discover again how little we really know about the universe. Still had the old Hubble Space Telescope on your screen? Many people have already forgotten about Hubble or think that the telescope is no longer active. However, Hubble continues to explore the universe every day, looking for new phenomena, and now received a completely unexpected direct hit. Hubble managed to find a new type of black hole. These so-called central black holes fill the gap between known stars and supermassive black holes. Their existence raises new questions and may now give us the key to the formation and evolution of galaxies. Black holes are a great example of how nature can be both extremely simple and profoundly beautiful. We are surprised to discover again how little we really know about the universe. Many people have already forgotten about Hubble or think that the telescope is no longer active. However, Hubble continues to explore the universe every day, looking for new phenomena, and now had a completely unexpected direct success. Hubble managed to find a new type of black hole. These so-called central black holes fill the gap between known stars and supermassive black holes. Their existence raises new questions and may now give us the key to the formation and evolution of galaxies. Black holes are truly a great testament to how fascinating nature is. They are so huge and mysterious that they remain one of the great mysteries of astrophysics. Until recently, only two types of black holes were known: stellar black holes, formed by the collapse of massive stars, and supermassive black holes, millions or billions of times heavier than the Sun and located in the centers of galaxies. The discovery of interstellar black holes surprisingly reveals to scientists that the cosmic landscape is much more complex than we thought. Intermediate black hole masses lie between stars and supermassive black holes. Their existence was proved by a careful analysis of the motion of the stars of the Messier 4 constellation. There, the stars showed striking motions that can only be explained by the presence of an extremely massive and very compact object. The first signs of this object were found by comparing data from the Hubble Space Telescope and the Gaia mission. This object has about 800 solar masses, making it significantly larger than small stars with masses of about 3 to 20 solar masses, and much smaller than the largest dark giants, which have several billion solar masses. The beauty and charm of these objects lies in their ability to influence and shape the light and matter around them. The beautiful shapes of galaxies and other structures in the universe are probably due to the activity of black holes. Now scientists must explain what role interstellar black holes play in this cosmic spectacle, and they may be the door to understanding the formation of galaxies. How are intermediate-level black holes studied? Have you ever wondered what methods scientists use to study invisible objects? Black holes are usually observable only because of their behavior. They bend space-time in extreme ways and thus magically attract other objects. The bigger the black hole, the stronger the pull. If you encountered a black hole in space, you wouldn't just see something there. You may notice a slight star distortion in the surroundings or background. Black holes are best seen when they absorb matter. If you could see matter gather into a big circle and become more and more distorted, you might think that a black hole is eating food. Scientists use spectroscopy to determine the emission of light and gases from objects orbiting stars or other black giants. Thanks to this method, we know quite well what the mass of black holes is and where they are located exactly. Scientists also detect intermediate black holes, IMBHs, through the gravitational lensing effect. As the IMBH passes distant light sources below, its gravity bends the light from those sources, making them brighter and more distorted. These distortions are excellent for determining the mass and location of the IMBH. Today, scientists rely more and more on the development of technology. The Hubble Space Telescope has already demonstrated that it can detect and analyze many black holes. But the new James Webb Space Telescope and Chandra X-ray Observatory are even better. They play an increasingly important role in the detection and study of these black giants. Both telescopes offer very high resolution and sensitivity, thus providing the best detail around the IMBH. ESA also launched the Gaia mission. This satellite maps the positions and movements of billions of stars in our galaxy with unprecedented precision. This information can help track the movement of stars in the vicinity of the IMBH and thus measure its gravitational influence. The Gaia data are now helping to identify other possible IMBH candidates in other galaxies. Theoretical astrophysicists use numerical simulations to reconstruct the dynamics of star clusters and the interactions between stars and IMBHs. The simulations should help to understand the formation and evolution of IMBHs and the conditions under which they can form. We need such models to put our observations in a proper context and to interpret the role of IMBHs in the cosmic interaction of forces and objects. Studying the motion of stars in dense clusters is another method for studying IMBHs. The presence of the IMBH affects the cluster dynamics by changing the stellar velocity distribution. By analyzing these motions, astronomers can again draw important conclusions about the mass and location of the IMBH. When observing the interactions of black holes with their stellar environment, researchers usually use a combination of several of these techniques to obtain the most accurate data. If the measured values of the different methods agree, this is a good indicator. Do black holes create galaxies? Since the launch of the James Webb Space Telescope, we have faced a cosmological conundrum. How many thousands of bright galaxies could there have been during what scientists have until now called the Dark Ages? Webb's deep images show us galaxies that existed only 300 million years after the Big Bang. This completely challenges our previous theories of galaxy evolution. And this is where black holes come into play again. Black holes probably have something to do with the formation of star clusters. Stars are not loosely distributed in the universe. They organize themselves into galaxies that always have a black hole in their center. Beautiful shapes like spirals, disks, or even vortices are probably due to the gravitational effects of central black holes. At the center of a galaxy, there is always a supermassive black hole. However, how it gets there, and when these black holes formed in the first place remains a mystery. Once we understand this, we can draw important conclusions about the evolution of the entire universe. Galaxies sometimes have many smaller stellar black holes. We've known this for a while. IMBHs join them, and it would be interesting to know what role these intermediate black holes play and how they form. Could they be black hole mergers of smaller stars, or do they form a category of their own? So far, what is certain is that the gravity of IMBHs affects the structure of star clusters and promotes or inhibits the formation of stars in their vicinity. This suggests complex interactions, and it almost seems that black holes are not just omnivorous monsters, but important shaping and regulating structures. Through improved observational methods, modern telescopes, and theoretical models, we are gaining more and more insight into the true role of these mysterious objects in the universe. Not long ago, Webb discovered a supermassive black hole, which raises more questions. It existed only 570 million years after the Big Bang and contains 10 million solar masses.
This is actually impossible by any known cosmological standard. A black hole can never grow that big in such a short time. Black holes usually grow by merging. Many small black holes lead to ever larger objects. Of course, super black holes in the centers of galaxies also grow as matter dissolves, but that increase in mass takes billions of years. There is a theory that the first black holes were not created by a supernova, but are a direct result of the collapse of large dust clouds. The process is essentially similar to star formation, except that the rapidly rotating cloud of dust collapses not into a star that undergoes nuclear fusion over millions or billions of years, but into a black hole. Simulations have shown that this is possible. However, the size of this black hole is unusual, as is its age. If black holes existed much earlier than previously thought, it could rewrite the history of the universe. Sir Roger Penrose publishes a theory in which black holes play an interesting key role. The idea of a cyclic universe roughly assumes that once massive black holes absorbed all matter, then they evaporate and eventually the universe collapses. After hibernation, which takes place outside of time and space, a new universe is born. Black holes, or their ultimate data, may be portals to the rebirth of a perfect universe. If this is true, we have so far underestimated the role of these objects. Many questions remain, and we need to advance our science to learn more about black holes. Ultimately, we still don't know for sure what's going on inside them. And until that is the case, we may not fully unlock the secrets of the universe. In theory, there is a point inside where all known forces increase to infinity. It sounds exciting, but this formula basically just says that our old physics fails here. It cannot understand or mathematically reproduce the processes or forces inside black holes. Last hope. Quantum computing. Sounds too good to be true. Imagine how one technology could solve all our problems. This is exactly what quantum computers could do in a few years or decades, especially when combined with artificial intelligence. Once these computing machines are in use, all astronomical and cosmological theories and known observational data can be fed into them. Quantum computers must be so powerful and intelligent that they can show us exactly what we are doing wrong. Quantum computers combined with artificial intelligence can even unlock all the secrets of the universe and tell us what happens inside a black hole, how the universe was created, and what its true nature is. Currently, these computers are still being tested. Quantum store all information in the universe and exist simultaneously in multiple times, dimensions, and spaces.